A quick update on floats, specifically singles for GCBASIC. So I'm going to walk you through this program, and then we're going to see some results on the screen. And the results on the screen should be, I'll program it now, and then we'll have a quick look in a moment. So the first thing I'm going to do is just define a constant called pi. 22 divided by 7, that just creates a constant, not part of the major program. I can now create some singles, and I've called my two here circumference and my radius. My circumference and my radius. I have another one that's called my diameter. It's also a single, but I'm aliasing that back into my circumference because I'm just saving a bit of memory, but I'm also proving the aliasing works. Cache turn line feed on my terminal. Let's see what the result is on the terminal, shall we? We've got a float test result number. It's 1,633 runs. It says here that my radius is 10.5. My circumference is calculated as 66, which is correct. For those who do maths, pi r times 2 pi r 2 pi r. The radius is equal to 10.4. 10.5, which is an equal sign, and as a string I'll show you that. And the diameter therefore of my circle is 21. So how are we doing that? Like we're saying, we've got my variables, we just define those. We're setting my radius to 10.5. We're doing some maths. We're saying multiply my radius by pi by 2, and then it's putting it on the screen. So this is the screen stuff. So the function in here is single to string, my radius and my circumference. So that's how that gets on the screen. And then there's some conditional tests. Those conditional tests. If my radius is greater than 10.5, then put a string on that says it's greater than 10.5. If it's equal to 10.5, put 10.5 on the screen. If it's less than 10.5, put less than 10.5 on the screen. And then it does another calculation using floating point. Maths, my diameter, calculates the diameter, and it puts it back on here. So let's have a look at an example piece of code. This one here is a good example. Shift F7 will open up the assembly. Here is the maths for that. It says here, first one is, it says put my radius, whatever the current value of my radius is, put it into a temporary variable called system A, it's a single temp A, and it puts the constant value of 2 into a temporary variable, and then it calls the functions out in the libraries for doing multiply singles. The result comes back, it puts the result of system temp X into system temp 1. It then puts the next set of numbers into the calculator and then calls it again, calls the second multiplication out as multiple as a single. So we can see here, this line of ASM here has successfully calculated from the single values at the top here. Then it puts it on the screen. If we look at the result on the screen, remind ourselves what we've got: 10.5, 66, 11, 10.5. So let's just put 11.5 in our source, and we'll see that this block here is working. We know the math's working. Now let's just check the conditional statements. If it's greater than 10.5, we should see a different result. So there's the result, 11.5 at the top. And it says that the diameter is 23, which is good enough for military work. Back in our source program, put 9 in here. We should now see this test come true. So it's not greater than 10.5, it's not equal to 10.5, it is less than 10.5. This is an explicit test, not an else, just because I wanted to make sure that works. And we get my radius is 9.5, circumference is less than 10.5, and the diameter is 19. What you're seeing on the screen now is the complete program. That's the end of the demonstration.